Hey everyone, welcome back to the Foundry by Forge College. So, in our last lesson, we really got our hands dirty manually untangling three-way merge conflicts. And let's be honest, that can feel a bit like trying to defuse a bomb, right? Well, for this explainer, we're taking a step back. We are building a technical blueprint for your Git workflows to basically stop those massive code pileups before they even happen. It's going to save your code base, and honestly, it'll probably save your sanity too. Here's our blueprint for today. We've got Section 1, branches as traffic lanes. Section 2, comparing branching strategies. Section 3, designing a team workflow. Section 4, the ultimate merge checklist. And then we'll wrap things up with Section 5, module review and next steps. Let's jump right in. All right, so we know exactly how to resolve conflicts mechanically now. But the real question is, how do we prevent chaotic merge collisions from happening in the very first place? Because without a solid strategy, throwing a team of developers at the exact same files is, well, it's basically a high-speed demolition derby. The secret sauce here is a rock-solid branching strategy. Which brings us to Section 1, branches as traffic lanes, the highway metaphor. I want you to picture your Git repository as a high-speed, multi-lane highway. If everyone is just driving in the exact same lane at wildly different speeds, you are absolutely going to get crashes. It's inevitable. So think of your main or release branch as the express lane. It's a long-lived branch, and it comes with incredibly strict rules. You can't just casually merge your code into it without paying the toll. And in this case, the toll means passing automated tests and rigorous code reviews. Traffic in the express lane has to flow smoothly and safely at all times. So if the main branch is the express lane, how do we actually get into it? Well, feature branches are your on-ramps. This is exactly where you accelerate your experimental work, completely in isolation. You build your feature, you test it out, and you match the speed of the traffic before seamlessly merging in. But here is the golden rule. On-ramps are short-lived. You definitely do not want to live on the on-ramp forever. Now, what happens when things actually break on mainnet? Because, it happens. When there is an absolute emergency, service lanes, like your hotfix branches, allow for critical, highly scoped patches to just bypass all those usual traffic jams. They exist for one sole purpose, to prevent a total standstill and get a crucial fix out to production literally immediately. Moving right along to Section 2, comparing branching strategies, finding your team's flow. Okay, so how do these highway concepts actually translate into real-world Git architectures? Let's break down the big three. First up, feature branching. This centers each task on its own totally isolated branch. It's fantastic for smaller teams, but keep in mind, if those branches live too long, they practically invite conflicts. Next, we have Git Flow. This adds heavy layers of structure with dedicated develop and release branches. It is absolutely perfect if you have scheduled QA releases, but it is pretty heavy on process. And finally, trunk-based development. This is all about maximizing speed. You make really frequent, super small merges directly into a main trunk. It's perfect for high-velocity teams, but man, it requires some bulletproof automated testing to pull off. Ultimately, choosing a strategy really comes down to your team's historical philosophy. Like, do you want a linear, perfectly tidy history? If so, you'd use rebase to smooth out your code's trajectory so it reads like a clean, single-file line. Or do you prefer explicit merge points? Standard merge commits preserve the exact historical context of when and exactly how features were added, even if that makes your Git graph look like a totally wild subway map. Neither way is wrong. It's really just about what makes your project easier to audit down the road. All right, Section 3, designing a team workflow. The default adaptable workflow. Let's turn all this theory into a practical workflow that you can drop right into your Solana projects today without causing any developer road rage. You need to enforce these core rules. First, use predictable machine-readable naming conventions. Second, absolutely keep branches under a week old. Third, integrate your small changes daily. And fourth, enforce strict review policies. Literally nothing hits that express lane without passing continuous integration checks and a solid peer review. No exceptions. Actually, if you take away just one single rule from this entire explainer, please make it this. Short-lived branches minimize conflict magnitude. The longer your branch sits there isolated, the more the main codebase drifts away from it. Try merging a month-old branch, and I guarantee you'll be staring down a terrifying 50-file merge conflict. Just keep them short and keep them sweet. Let's look at Section 4, the ultimate merge checklist, reproducible steps for every merge. So let's translate that golden rule into your daily commute. You want to follow these reproducible steps religiously. Step 1,
Always update your local branch by fetching and rebasing so you can deal with any conflicts privately. Step 2, run your local tests. Seriously, don't waste your reviewers' time with broken code. Step 3, open up a descriptive pull request. Step 4, if conflicts do happen, resolve them super carefully, making sure you always preserve the other developer's intent. And finally, step 5, merge and then immediately delete that feature branch. Demolish the on-ramp so nobody accidentally reuses it.
And finally, Section 5, Module Review and Next Steps, wrapping up version control. We have covered a massive amount of ground in this module. To synthesize it all, your branch choices directly dictate your conflict frequency. The big 3 strategies we talked about basically trade off process overhead for release clarity, and keeping your branches short-lived is absolutely your best defense against code drift. So your action item for today? Draft a simple 1-page branching strategy document, something like a contributing.md file, just so your whole team is playing by the exact same rules. I want to leave you with this one thought. As your Web3 project scales from, say, 2 developers up to 20, how will your code-based traffic control need to evolve to prevent total gridlock? Because what works for a dynamic duo might honestly cause a massive pileup for a larger team. Really think about that as you continue to build. Thank you so much for joining us for this explainer, and please make sure you visit forge.college to explore more Web3 educational resources. We will see you in the next module.